Hello, good morning students. In today's class we have discussed two concepts. One concept, basic introduction of reliability and quality. Already we have discussed in previous video. So next continuation of that, for the benefit of students, I can making this video. Okay, then we have to go for discussion of system reliability. It is already well known in your Indian system we have using integrated power system. Still we are dreaming to go for trading electricity in coming days. So in this respect, the reliability and quality of electricity are becoming main factors. The consumers, they want their electricity, uninterrupted electricity, and second one, quality. It is not burden of customer, it is the burden of utility. So utility has to plan, has to decide, has to implement what type of power supply should be supplied to the consumers and what is the level of reliability is required. Because if I talk the reliability, then it comes investment. Every system is designed to be economical. Every system is designed to be economical. In sometimes in electrical machine design, in power system design, we concentrate on efficiency and reliability of the system and quality of the supply. Hence, cost becomes secondary. If I am thinking about cost, then standard efficiency machine is not available. High quality reliability is not available. These statements are decided by the designer. In this respect, we have to discuss the system reliability. Already I told, system means integrated entire power system. The utility has to plan in such a way that the supply of electricity as per consumer satisfaction level, because the consumers want only two things. Number one, uninterrupted power supply for their applications. Second one, they have to need quality of electricity. That means their equipments are not to be affected. Such supply they want. That means voltage variation in the supply, frequency variation in the supply is not required. These two conditions, voltage and frequency, will affect the consumer electrical equipments. Hence, they doesn't want to damage their equipments. This is the one idea. The higher reliability can be achieved by making sufficient investment on power system. High quality equipments are required. That I told, utility has to investment to purchase better controlling equipments, better software, better sensors, better high technology. These are to maintain for high reliability, and some part maintenance is also indirectly helping. If improper maintenance is there, it also cause the outage or shutdown. For example, if one system is working under software and remote automatic control method, one example you take, boiler, some oil level, temperature should be maintained 80 degrees centigrade. This is the final, this is the target. Before that two threshold values are set. One is 60 degree, another one is 70 degree. When the boiler temperature reaches the 60 degree, first alarm, first buzzer is given. Then electrical engineers should take the action to overcome such part. It shows in the SCADA system. Then if first alarm, first information is not attended, after some time, after some seconds, second alarm should be buzzed. Then we should take the awareness. It should be mitigated. It should be cleared. Otherwise, third time the unit is going to shut down. Hence, this example shows that our maintenance is also affect on the outage or shutdown. Hence, this is the one important criteria. The economic and reliability constraints are conflicting. That means confusing. If I tells high level of reliability, I need high level of investment. That's why economic is not possible. But every system is designed to economy because consumer wants economical power supply. They doesn't bother about the reliability. They want only quality power and economical, less cost power. But utility have to think what level of reliability we have to produce. Reliability directly proportional to economy. If reliability level increases, investment increases. Investment increases, economical condition increases. Hence, too much high reliability is also not required. Too much low reliability is also not required. It is confusing. The planner or electrical engineer should take a correct decision. Next continuation of that, the reliability of power supply to the consumer is judged by frequency of interruptions. I told it is directly proportional. Which reliability is good? Consumer want less number of interruption of power supply and duration of each interruption, how much time power is off, and value of consumers. Sir, value of consumers means what purpose the consumers are utilizing this electricity. For example, farmers are using such a electricity for pumping of water, in domestic applications for preparation of food, same in industry for driving the mechanical drives. These are called different applications. You can go for in stadium, you can go for viewing of TV, you can go for film theaters. So many applications are depends on electricity. Hence, power is down. Then at that time when the power is not available, value of consumers is also affecting on reliability. To increase the reliability, it is necessary to understand the causes. To understand the thing, reliability, it is necessary to understand the causes of outages and types of equipment failures. The most typical causes for the outages are the equipments are using in utility. The failure may be occurs due to many causes. We have to know. That means planner have to know what cause the outage may occur. Number one, power utility equipment failure. Consumer equipment failure. If consumers are using different type of protection, different type of equipments, or earthing, or MCCB, or RCCB, or improper operation, there are so many things. Next, dig in for cables. When you are making digging, the cables may be there, that also occurs. And trees, falls of trees due to different seasons, due to rainy season or due to high velocity of air, pollution is also affect. Storm, flood, lightning, accidents, power shortage, system inadequacy, theft of power. These are all major outages which may cause the faults. Hence, the designer are to be kept in mind. Second, another important fact is that environmental considerations. That is also important. Environmental like high temperature, dust, thunderstorms, high humidity, heavy rains fall, high wind velocities are different parts of the country are different. That means in the different parts of the country, different of the exposures will occur. It may be important in design of transmission and distribution lines, and it may be also important on system reliability conditions. And another important thing is also workmanship of some cases, that is dedicated service is required wherever manual operation is required. The value of consumer is determined by the benefits of electricity. For what purpose the consumers are using the electricity? I already discussed preparation of foods, getting light, TV views, air conditioning, heating systems, cooling systems in shops, in offices, in industries. You go on listing, and pumping of water in agriculture sector. These are all called benefits of electricity to the consumers. It also affect and increase in standard of living. The every man needs standard electrical equipments for their use in daily life. Hence, the standardization of human lives depends on electricity. It goes on increasing. That means demand of electricity also goes on increasing. The individual reliability of equipment, circuit length, loading, network arrangement and consumer values also determines the reliability. Next one, this is one part. Next we have to see some terms before going to reliability design. Another two factors are very much important. One is known as system adequacy, one is known as system security. You have to know these terms, then we have to enter design of reliability. The adequacy of the system is defined as capability of the system to meet the system demand in case of scheduled or unscheduled outages. It is known as adequacy. The system security is defined as its ability to avoid or to limit the major outages which collapse the entire power system. The power system should work on dynamic condition. If any faults or occurs, then system should be under stable. It is called system security. Security is the capability of system to withstand the disturbances. Understand once again. Security is the capability of system withstand the disturbances. The disturbances arising from faults, unscheduled removal of equipments without affecting further loss of facility on system. That means if any fault occurs in entire power system, that zonal part can be removed, cut off, and remaining part will function in that power system. This is the idea. But entire power system should not collapse. Immediately you have to take the action, remove that faulty zone, then entire zone in the power system should carry out further work. Adequacy also relates the sufficient facilities in the system. What type of facilities, equipments, software systems are providing, that information is also referred as adequacy. It also relates to the static condition. It is not applicable for dynamic condition. Adequacy relates to static condition. When the power system is working, such a situation is called dynamic condition. So our security system is applicable to dynamic situation, dynamic conditions of power system. The design of power system should be such that it should have high reliability, neither economical nor technical feasible. Hence, all systems are designed with consideration of economy. In few cases, as per need of consumers, we have to go for higher reliability. Then it secondary becomes economical. Economical becomes secondary. The main aim of utility to serve various demands of energy with economical for acceptable quality of consumers. The task of power system planning is to configure the electrical power system with compromise between requirements and adequacy and security to attain continuity and quality of supply. This point is very much important. What level of reliability is required, what level of quality is required, because there is some specifications are given on the equipment, standard variations. While preparing such equipments, the equipments are designed to carry plus or 5% variation of frequency, plus or 5% variation of frequency or voltage. On consideration of that, the reliability levels are designed. So thank you to one and all.